Hello, Mechanics OM here, and today we have a rigid body which length is equal to 2 times L, a steel rope ACDE, which is mounted on pulleys C and D. They are assumed to be frictionless, weightless, and also very small. At point A acts a force which is equal to F. At point B we have a pinned joint. We also know that steel ropes modulus of elasticity or Yohn's modulus is equal to E and the section area is equal to A. So what we need to do is find how much did the length of steel rope ACDE change and what is the deflection of point A. So if you want, pause the video and give this problem a try. So now let's get started. So to solve this problem, we need to draw a free body diagram of rigid body AB. So let's do this. Okay, point B, point E, and point A. Okay, so at this point we know that there are two reaction forces which are equal to Fy, the vertical force, and the horizontal force Fx. We also know that at the point A acts a force which is equal to F, and at points A and E acts a force which is equal to steel rope's tensile force. So, assuming that pulleys are frictionless and weightless, we can assume that forces acting at point A and E are equal, and it is equal to, for example, capital N. Okay, so now we need to find the value of these forces. So to do this, we can write a moment equilibrium equation with respect to point B. So let's do this. The sum of moments with respect to point B must be equal to 0, and forces which rotate a rigid body with respect to point B counterclockwise will be positive. Okay, so let's write it. F times 2L. Oh, I forgot dimensions. Okay, L minus N times 2L minus N times L, and it is equal to 0. And from this we get that N is equal to 2/3 of F. Okay, so now from Hooke's law we know that normal stresses is equal to modulus of elasticity or Yohn's modulus times relative deformation. Okay, so normal stresses in steel rope can be calculated as tensile force divided by section area. Tensile force is equal to N divided by A is section area is equal to E times epsilon. And it is equal. We know that relative deformation can be expressed as change of length of steel rope ACDE divided by initial length, and initial length, assuming that pulleys are very small, can be calculated as 3 times L. So from this we get that delta ACDE or change of length is equal to 3N times L divided by EA. And now, knowing that N is equal to 2/3 of F, we can write that 2/3 of F times 3L divided by EA and it is equal to 2FL divided by EA. Okay, so now we answered the first question. Okay, so now let's get to the second question. So to answer second question, we need to draw a deformed scheme of rigid body. Okay, so let's draw point B. Okay, here it is an initial scheme. Okay, point A, point E, and assuming that deflections or displacements are very small, we can assume that those points move only vertically. So the deflection of A can be written as U, for example. And the deflection of point E can be expressed as U1. So I forgot dimensions. Okay, LL. And here's what we can see is two similar triangles. And we now can write that U divided by U1 is equal to 2L divided by L. And from this we get that U1 is equal to U divided by 2. That means that U1, or displacement of point E, is 2 times smaller than displacement of point A from similar triangles. So we also know that if we sum those two displacements, we get a change of length of steel rope. So let's write it down. U plus U1 is equal to change of A, C, D, E. And we know from previous question that length change is equal to 2FL divided by EA. So let's put in this equation. 2FL divided by EA. And we also know from this equation that U1 is equal to displacement of A, or U divided by 2. So let's put it in this equation. U plus U divided by 2 is equal to FL divided by EA. So now from this we get that U is equal to 4FL divided by 3EA. So that is the answer. Hope you enjoyed the video. Please subscribe and like. Goodbye.